Hi viewers, this is Sri Ramulu. So today's topic is dielectric polarization and charge density. Right? So first, what is a dielectric? Dielectric is a bad conductor or insulator. It is a insulator. So why it is an insulator? So what is the meaning of insulator or bad conductor? A substance which cannot allow the electricity through them. That substance is called a bad conductor or insulator, and it is also called as dielectric material. Okay, so that is the definition of dielectric material. And here dielectric, many examples are there. So dielectric material, glass, plastic, and air is also one type of dielectric material, mica. Okay, so like this many substances are there, dielectric material. So here one example is a glass. Let a dielectric slab is placed between the two metallic plates which can be charged to equal and opposite charges. Here, what is the meaning? Here, two plates are placed. Here, it is one plate, is another plate, plate A and plate B. In between these two plates, what is kept? There is a one glass material or dielectric material is placed, and uh, plates can be this plate can be charged. That means we can charge it with a negative, or we can charge it positive. If we charge it a negative, then we have to charge with positive. So if you charge it with positive, then charge it with negative. Figure A shows, here the figure, there are the two figures are there, figure A and figure B. So this is a figure A. Figure A shows the electronic structure of an atom when the two plates are not charged. So plate A and plate B are not charged. So inside what is kept? One dielectric substance is kept. So when the dielectric plate substance is like this, then inside the dielectric material atom present, and all the atoms may have at the center positive charge, and around it a negative charges present like this. Okay, so see the negative charges are around it completely like this. Now figure B, see the figure B. Figure B shows when the plates are charged. Here A plate, B plate is charged here. Okay, in figure B. So A plate is charged with a negative and B plate is charged with a positive. Now what happens? See here, electrons are slightly displaced towards the positively charged plates. Here B plate is positively charged plate. So around the atom, around the nucleus, negative charges are present. So these negative charges are displaced this side. See, this side negative charges are displaced. Why? Plate B is a positive charge, so positive charged plate can attract the negative charged ions or charges. Okay. While the positively charged nucleus towards the negatively charged plate. So it is a nucleus, and see it is attracted this side. Here, see the nucleus is here, it is present. So it is displaced this side. So like this, when the two opposite charges are separated at a certain distance, then we call that is a dipole. Okay, dipole. Now see that dipole definition. The electronic displacement is a function of magnitude of the charges on the plates and the nature of the dielectric. So this displacement of negative charges is depend upon these charges. If there are the more charges present, then they displace large number of opposite and this side, and opposite and this side. And material depends upon the nature of the material also. If the material has a more number of atoms, then large number of ions can displace. In this way, dielectric is acted upon by the forces and is said to be polarized. That is the meaning of polarization. Okay, so in this way the dielectric is acted upon by the, so because of here attraction forces only. Here negatively charged charges are attracting positive charges, so attraction force present, and this side also attraction force present. Now the distorted atom is called electric dipole. Distorted atom means a atom in which the ions are or charges are displaced. So that is a distorted atom. And we know that electric dipole has dipole moment. So what is the meaning of dipole moment? Here just now we have seen positive charges and means the nucleus are displaced this side, and negative charges, more negative charges are displaced this side. So when the two opposite charges are displaced at a certain distance, if they present at a certain distance, means a small distance, then this is called dipole moment. So sorry, it is called dipole. And suppose it is positive charge, it is negative charge, and if these two are separated at a distance 2a, okay, then product of distance between them and a magnitude of charge is called dipole moment. Okay, so that is the meaning of dipole moment. Dipole moment is 2aq is equals to p. Product of distance between them and a magnitude of charge is called dipole moment. So like this dipole moment present. And how many dipole moments are there per unit volume? That is called polarization. Here definition C. Electric dipole moment per unit volume is called dielectric polarization. Okay, in one unit volume, how many moments present? That is called polarization. Suppose a dielectric slab of area of cross section A and a length L is placed in an electric field as shown in figure. See, the side figure is there. So that means we are going to calculate the one formula for polarization. Suppose a dielectric slab of area of cross section A and a length L is placed in an electric field as shown in figure. So it is a diagram. Okay, so it is a slab, dielectric slab, length, that is a glass, just now I explained you, and its length is L. Okay, and its area of cross section is A. Here I am going to consider the two faces. Let the induced charges on the face ABCD and EFGHB minus Q dash and plus Q dash. So induced charges mean, generally charges mean if you keep from any charges outside, that is the charges. Induced charges means they have to generate inside the substance only, that is induced charges. They are denoted by dash. Okay, so here on ABCD face, which charge is there? Negative charge. It is ABCD face, negative charge, and EFGH face, positive charge. So EFGH face, positive charge, and these two charges are separated at a distance L. So distance between the two charges is L. The dipole moment will be Q dash L. So just now I explained the dipole moment is distance between two opposite charges into magnitude of charge is called dipole moment. So magnitude of charge is Q and its distance is L. So that is a dipole moment, it is P. As the volume of the slab is AL. So volume of the slab is, its area is A and a length is L. Product of area into length is called volume. Hence electric dipole moments per unit volume. So dipole moment, so here the polarization definition is what? Polarization definition is dipole moment per unit volume. So dipole moment by unit volume, that is the definition. Here dipole moment is how much? It is a dipole moment Q dash L. Okay, and a volume is how much? It is AL. So this by this, it is called a polarization, Q dash L by AL. L cancel, Q dash by A. Already we know Q dash by A is also called as surface charge density. So that is why in the beginning, if you observe the beginning side heading, so two side headings are there: dielectric polarization and charge density. Here charge density is sigma charge density. So because of that, only two side headings are kept. Hence dielectric polarization is numerically equal to induced surface charge density. So generally these charges are induced charges, so that is why this density is called induced surface charge density. Okay, so here polarization is nothing but surface charge density, that is induced surface charge density only. Okay, so this is the friend, don't forget